All right, this is the part 1 of the Unit 12 test study guide. First topic is on trig functions. So we learned the 6 trig functions, different ways that you can evaluate different pieces. So the first couple, we are just finding the 6 trig functions. You are given either 2 sides of a triangle or one of the 6 trig functions. So this first one, you have 2 sides of a triangle. Very first thing you need to do here is figure out the missing piece using the Pythagorean theorem. Make sure that the missing piece is going into the right spot. So the missing piece is a leg, so that'll be on the left-hand side. So x squared plus the other leg, and then the hypotenuse. All right, so we can evaluate these. And as I'm going through, like if numbers just appear, just trust that, I'm plugging them into my calculator. You would get the same ones. So x squared plus 18 squared is 324 equals 21 squared, which is 441. Then to get the x squared by itself, we would subtract the 324 from both sides. So 441 minus 324 leaves us with 117. And 117 you can actually split into 9 times 13. So 9 times 13, 9 is the perfect square. So when you take the square root of both sides, x equals, the square root of 9 comes out, and then the 13 stays behind. So again, the 117 was split into the square root of 9 and the square root of 13. So once we do that, we've got the last side that we can measure on here, so 3 root 13. And as soon as you know that, now this is the adjacent side to our angle theta, and so we can use that in all of these formulas. So sine is opposite over hypotenuse, so opposite to this theta is 18. The hypotenuse is 21, and that reduces down to 6 over 7. The cosecant is the reciprocal, so that flips to 7 over 6. Cosine is the adjacent over the hypotenuse, so 3 root 13 over the hypotenuse, and the 3 over 21 reduces down to 1 over 7. And then flip, so this flips to 7 over the square root of 13, and then I can rationalize it by multiplying by root 13 over root 13. So I get 7 root 13 over 13, and then the 7 over 13 does not reduce. And tangent is opposite over adjacent. So we have opposite over adjacent. So first thing, the 8 over 3 reduces down to 6. And then I would have to rationalize that. So I end up with 6 root 13 over 13. And then when I flip, I actually want to flip the unrationalized version. So this is 6 over the square root of 13. So this flips to the square root of 13 over 6. All right, so that is my first one. Second one, we've got one of the 6 trig functions, so that's 2/7. That automatically gives us one of the other ones, just knowing that it's the reciprocal. What I use this for is to figure out my missing piece. So remember, 2/7, you can just kind of draw just a generic right triangle. So opposite over adjacent. So we would call this the angle, so opposite over adjacent. What we're missing is the hypotenuse. We can use Pythagorean theorem to solve for that. So a squared plus b squared equals c squared. So that's the missing piece, the hypotenuse. So 4 plus 49 equals x squared. When I add this left-hand side together, I get 53. And then I solve by taking the square roots. And the square root of 53 is not anything that can be broken down any further than it already is. So write the root 53 in there. This means we're definitely going to have some rationalizing when we set these up. So sine is the opposite over the hypotenuse. And I am going to have to rationalize this. Let's actually flip it before I rationalize it, just to make things easier. Rationalize this, you'd multiply by root 53 over root 53. So we end up with this, which does not reduce. Cosine is the adjacent side over the hypotenuse. So we're going to have to rationalize it. Might as well flip before we rationalize, so you don't have to re-rationalize. And then this multiply by root 53 over root 53. So that is all 7 of those trig functions. Number 3, we've got one of the pieces here again. So this is secant. We've got 4 root 2 over 3. So we can flip that to find cosine. So we have 3 over 4 root 2. And we can rationalize that, multiply by root 2 over root 2. So we multiply this by root 2. When you multiply the denominator by root 2, the 4 and the root 2 and the root 2 would end up being 4 times just 2, which is 8. All right, so we've got 2 of the 6. We're going to do the exact same thing. You can draw just a very generic right triangle to label on some pieces. So secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. That makes the secant hypotenuse over adjacent. So hypotenuse, adjacent. So we need to find that third piece. All right, so a squared plus b squared equals c squared. So this is 9 plus our missing piece. When I square this, I square the 4, which is 16, and I square the square root of 2, which is 2. So that ends up giving me 32. Subtract the 9 from both sides. So 32 minus 9 is 23. So I end up with another square root that I'm going to have to simplify. So square root of 23, that's my opposite side. And 23 is a prime number, so it doesn't go any further than that. So sine is the opposite over the hypotenuse. So the square root of 23 over 4 root 2. So this one I can rationalize, multiply root 2 over root 2. So then I multiply the top by root 2, I multiply the number underneath, and I get root 46. And remember, when I multiply this one by root 2, I end up with 8s. So cosecant, we can flip it now, we can flip it later. Either way, we're going to have to do some rationalizing. So you might as well flip the beginning one, since you're going to have to rationalize it anyway. So multiply by root 23 over root 23. So the 4 would still be out front. When I multiply the roots, I get this, and then the denominator is now just a 23. I'd get the exact same thing if I had flipped this and rationalized it. I just would have had some stuff to reduce. All right, and then tangent. Tangent is opposite over adjacent. So this is actually the only one that does not need to be rationalized. The last one, when I